In this video, we'll be using the first derivative to find the relative extrema of a function. If the derivative changes from negative to positive at some value c, then f of c is a relative minimum of f. Remember that the derivative is the slope of the tangent line. So if our tangent line has a negative slope, and then it has a positive slope, our value f of c is a relative minimum. If the derivative changes from positive to negative at some value c, then f of c is a relative maximum. So if we have a tangent line with a positive slope, and then a tangent line with a negative slope, this point will be our relative max. And then if the derivative does not change sign at c, then f of c is neither a relative min nor a relative max. In our example that we're going to work with, we're asked to find the relative extrema of the function f of x equals the quantity x squared minus 4, all of that raised to the 2/3 power. Now our first step will be to find the critical numbers. And we do that by first finding the derivative of f. So that will be 2/3 times this quantity raised to the 2/3 minus 1, which is negative 1/3. And then multiply that by the derivative of what's inside. So inside we have x squared minus 4. The derivative of that's going to be 2x. Now I want to set this derivative equal to 0. I'm going to write it as a fraction. So I have 0 equals, in the numerator I have 2 times x. And in the denominator I have 3, and then this is the same as cube root of x squared minus 4. So my derivative will equal 0 when the numerator is 0. So x equals 0. I'll also have a critical number when f prime does not exist. And that happens when this denominator is 0. So x squared minus 4 is equal to 0. X squared is equal to 4. X is equal to plus or minus 2. So our critical numbers then are 0 and plus or minus 2. Now we don't have a specific interval to work with here, so my set of real numbers is divided into 4 intervals by our critical numbers. And our next step is to choose test values in each of these intervals and then find the value of the derivative with those test values. So Let's choose -3, -1, +1, and +3. Now remember, we can use any test value as long as it's in that interval. So we wish to find the value of our derivative at each of these. So f prime at -3, f prime at -1, f prime at 1, and f prime at 3. My derivative was 4x divided by 3 times the cube root of x squared minus 4 and I need to put my test values in here. -2.34, -0.92, -0.92, -2.34. Now we didn't need a lot of accuracy with those because all we're really interested in is the sign of the derivative in this interval. Right? So we see that the derivative is negative on the left side of this critical number. The derivative is positive on the right side. And so this number, this critical number, is representing a minimum. On this interval, I have a positive derivative. On this interval, I have a negative. So this critical number represents a max. And then in this interval, I have a negative. This interval is a positive, so this critical number is a minimum. Now we represent our relative extrema with ordered pairs. So I need to find f of -2, f of 0, and f of 2. My function was x squared minus 4 raised to the 2/3 power. So f of -2 this is 4 minus 4, so f of -2 is 0. And this is an even function, so f of +2 is going to be the same value. F of 0 is 0 squared minus 4 to the 2/3. So -4 squared is 16. The cube root of 16. This simplifies to 16 is 2 to the 4th power. So this simplifies to 2 times the cube root of 2. So I can state then that I have relative min at -2, 0, and 2, 0, and I have a relative max at 0 to cube root of 2.